You know that feeling when you're in an argument and you just know you're right, but you can't quite prove it? Well, what if I told you there's a math tool that can actually settle those debates? Today, we're going to break down something that tells you what's really going on in the world around you, all by looking at the data. And to kick things off, let's dive into a classic friendly argument. So, picture this. Two friends, Sid and John. They're out on a camping trip, just chilling, doing a little fishing. But what starts out as a super relaxed afternoon is about to turn into a friendly face-off. So John's watching his buddy Sid, and from where he's standing, it totally looks like Sid is some kind of fishing master, pulling in a fish with every single cast. John's starting to think he's got no luck at all. But Sid's not so sure. He thinks they're doing about the same. And right here is where things get real interesting. So who's actually right? Is Sid the fishing legend, or is John doing just as well? How do we get past that gut feeling and figure out what's really happening? This is the perfect moment to use a little data instead of just, drama. The tool we're going to use to solve this whole fishing mystery is called empirical probability. Now, I know that sounds super fancy, but honestly, just think of it as probability's cooler, more down-to-earth twin. It's all about what actually happens in real life. Okay. Deep breath. Here's the official textbook definition. And yeah, I see those words, ratio, favorable outcomes. It sounds a little dry, but stick with me for a second. I promise this concept is not just a fluke. We're about to make this super simple. Here's the absolute bottom line. You've probably heard of regular or theoretical probability. That's what should happen in a perfect world. A coin has a 50-50 chance of landing on heads. But empirical probability, that's what did happen when you actually did it. It's all about the real-world results. So, before we solve our big fishing mystery, we gotta learn the basic moves, right? Let's do a quick practice round with some different data just to get the hang of this. For our practice, we're going to look at a survey where a bunch of students were asked for their favorite school subject. And yeah, you can see right away, social studies and English are doing pretty well. Math, well, let's just say math has some fans, but it's not exactly winning any popularity contests here. All right, don't let this table freak you out. It's actually super simple. All it's showing us is the breakdown of that survey. In the first column, you got the subjects. And in the second, you have the exact number of students who voted for each one, like 100 for English, 25 for math. The most important number is at the bottom. 400 total students were asked. That's our total experiment. Let's use these numbers. Okay, first mission. Let's say you picked one student completely at random from this whole group. What's the probability that their favorite subject is English? It is literally as easy as 1, 2, 3. Step 1, find the number of times the thing you want actually happened. Step 2, find the total number of tries. And step 3, you just divide them. That's it. Okay, step 1, how many students picked English? We just saw it on the chart, right? 100 students said English was their favorite. That's our favorable outcome. And step 2, what was the grand total? The survey asked 400 students. Boom, that's our total number of experiments. And now for the big finale, step 3, we divide. 100 divided by 400, which, if you simplify it, is 1/4, or 0.25. That means there's a 25% chance that a random student loves English the most. See, fractions don't have to be the common denominator of your problems. Let's do a super quick one for math, just for fun. We know 25 students picked it out of the 400 total. So 25 divided by 400 gives us a probability of just over 6%. I guess you could say the odds were kind of stacked against it. Okay, that was pretty simple, right? But what if you get a trickier question? Like, what's the probability a student's favorite subject is English or math? For stuff like that, we just need a quick little level up. Here's a pro tip, like a little cheat code for you. When you see the word or in a problem, that means your options are getting bigger, so you add the probabilities together. But when you see the word and, you're looking for two specific things to happen at once, which is way harder, so you multiply. That's a super handy trick to remember. So right about now, you might be thinking, okay, this is kind of neat, but seriously, when am I ever going to use this? And the answer is, you already are. You use this stuff literally every single day and probably don't even notice. No, seriously, think about it. A baseball player's batting average, that's just their number of hits divided by the total times they were at bat. That super rare item drop in your favorite video game, pure empirical probability. That 30% chance of rain on your weather app, or even which TikToks go viral. It's all based on what did happen in the past to predict what might happen next. So what about Sid and John? Now that you're an expert, let's solve it. Let's say Sid cast his line 20 times and caught 10 fish. His probability is 10 over 20. That's 50%. But what if John only cast 10 times and caught 5 fish? Well, his probability is 5 over 10, which is also 50%. It turns out John's gut feeling was wrong. The data proves they were having the exact same amount of luck. This isn't just some random math concept. It's a real tool for describing your world with numbers. And just like that, you did it. You are now officially a probability expert. You now know how to look at what happened in the past to make a really solid guess about what's coming next. Pretty awesome, right? So, I'll leave you with this one last question. Now that you know what to look for, what do you think is the empirical probability that you'll see this being used somewhere in your life tomorrow? Something to think about. Thanks for hanging out.